All right, 7.1D lesson, we're problem solving with area. So we're using the area knowledge that we gained from the last couple lessons and now applying these to some irregular shapes that are kind of coupled with some word problems. Okay, so Jeremy needs to buy soil for the garden in his backyard. A sketch of the plot is to the right. Find the area of the garden. Okay, so let me scooch this picture away from me here, my picture. All right, so you could choose to cut this up into 3 rectangles and add them all together, but I think the easiest way would be to think of the entire thing of 14 by 10 and then take out the 6 by 4. Okay, so we're gonna have the area of the big thing minus the area of the small rectangle. So we're going to have base times height of the big one, 14 by 10, minus the area of the smaller one, 6 by 4. 140 minus 24 gets us a 116. So 116, and we need feet, I think it was, yep, feet squared. Okay, so there's your area. How many feet of fencing will he need to enclose the garden if he fences the exact shape of the garden? All right, so to know about fencing, that should be a big indicator that you are finding the perimeter of this thing. So we're going to need the side lengths of all the sides. Okay, so do you understand that we would have a 14, a 10, and then we'd need to find these two pieces? These two pieces, if this piece is 6, these two pieces together are 8 because the whole thing is 14. Okay, so this would be 4 feet. Let me put the feet in there, and 4 feet. And if this is 4 feet, this will be 4 feet. And if this is 10 feet, this will be 10 feet. Okay, and then I'm going to kind of just mark where I start because there's a bunch of stuff being added together. So I don't want to lose track where I start and then where I leave off. Okay, so I'm going to start here and walk around the shape. So I've got 10 plus 4 plus 4 plus 6 plus 4 plus 4 plus 10 plus 14. All right, so adding all these up, 14, 18, 24, 28, 32, 42, 56, I'm getting 56 feet of fencing is needed. All right, number 2, Kara and Charisse are in a quilting competition. Both are stitching rectangular shaped quilts. So far, Kara's quilt has an area of 2,278 square inches with a length of 44 inches. Charissa's quilt has an area of 2,276 square inches and a length of 47 inches. Whose quilt is wider? Approximately how many inches is it wider? Round to the nearest hundredth. Okay, so we need to find the width in both. Okay, so let's look at Kara here. Kara, we know that her quilt, the area is 2,278 inches squared, and we know that 44 inches is her length. Okay, Charisse, her quilt we know is 2,276 inches squared, and her length is 47 inches. Okay, so area equals length times width is the formula, and we're going to plug 2,278 on this side, 44 for the L, and we're finding the W. Divide by 44. And that comes out to be, it says round to the nearest hundredth. So the width of Kara's comes out to be about 51.77. Okay, so Kara's width is 51.77 inches. All right, now Charisse, we're going to do the same thing. A equal L times W. 2276 goes in for A. 47 goes in for L. So we're going to divide by 47. And that gets us about a figure of 48.42. So Charisse's width is 48.42 inches. All right, so Kara's is wider. That answers the first question. Whose quilt is wider? Kara's is wider. And then we need to subtract these to get approximately how many inches is it wider. Okay, so Kara's is wider by about 51.77 minus 48.42 gets us 3.35. So here are your answers. Let me scooch that to the left a tad. Okay, there are your answers with all of the work shown. Alrighty. Rufina on our next problem. Rufina bought two 12-foot pieces of lumber and two 8-foot pieces of lumber to create a border for her garden in her yard. She wants to use all the wood to enclose her garden, and she has to saw to cut the lumber into different lengths. How should she use the 4 pieces to create a rectangular garden of largest possible area? What is the largest area she can get with her 4 pieces of wood? All right, so we have two 12-foots, that's 24 feet, and two 8-foots, that's 16 feet. So together, the total feet is going to be 2 times 12 plus 2 times 8, which is 40 feet. Okay, so we need to think about options of side lengths that help us to get to 40 feet total. Okay, we want to use all of it. So if we did 1 by 19, we would have 2 plus 38, that works. 2 by 18, that would be 4 and 36, that works. 3 and 17 works. So you want to get every combination that adds, these all add to 20, right? So that's what we're shooting for here. So 4 by 16 would work, 5 by 15 would work, 6 by 14 would work, 7 by 13 would work, 8 by 12 would work. And that is where it would end. Okay, so we're going to go ahead and think about the largest area. The largest area would be this guy right here. This would give us the largest area if we multiplied that. Okay, and then, so that answers that question, 8 feet by 12 feet. And then if you can cut more, okay, if more cuts are made, you can think about a 9 by 11. And you can also think about a 10 by 10. This gives us a 99 feet squared area. This gives us 100 feet squared area. This 8 by 12 over here gave us a 96 feet squared. Okay, so using the pieces that we had without cuts, this is your information. And then if you can make more cuts, you can get a greater amount of area if you cut the wood more, okay, and more pieces. Okay, number 4, a triangle has an area of 90 square centimeters. If its height is 15 centimeters, what is the length of its base? Okay, well, let's think about, so our area is 90 centimeters squared, and we have a height of 15 centimeters, and we want to find the base. Okay, well, the formula is 1/2 base times height. 90 goes in for the A, 1/2 B times 15. All right, so I'm gonna tighten this up a bit. This would be 15/2 B. Okay, can't I multiply this by 2 and divide by 15? I'm going to do that all at once. Okay, and when I do that, I get 1B equals, I would have 12 here. 90 times 2 is 180 divided by 15 gets 12. Or you can cross cancel the 90 and the 15 of it and get 6 times 2 is 12. Okay, so the base is 12 centimeters. The base is 12 centimeters. Sketch a triangle with an area of 90 square centimeters, height of 15 centimeters, and a base you found in part A. Is there more than one triangle you can draw with those dimensions? Yes. Okay, so I did a sketch over here. Couldn't I also do this sketch? There's another sketch. Let me scooch it away from my picture. All right, a new triangle has an area that is 150% of the original 90 centimeter squared triangle. If the height remains 15 centimeters, what would the new base have to be? All right, well, let's use our proportional knowledge from last module. I am looking for 150% over 100. And then I want to know what that would be if the original area was 90. Okay, so if I cross multiply, I'd have 100x equal, that came out to be 13,500. And then if I divide by 100 here, I'm going to squeeze that in right here, divide by 100, divide by 100, 135. X equal 135. Okay, so 135, that's our new area. Let me put that, X is, oh no, that's the new base. What is the new base? Nope, that we're gonna find the new base. That is the new area. And then we have to take that area and plug it in right here to find the new base. And it said that the height remained 15. So there's our new formula. We just needed to find that 135, that new area with the 90 blowing up, 150%. Okay, so let's go ahead and solve this. I'm going to put 15/2 here with a B, and then I'm going to multiply both sides by 2/15, just like I did on this one above. Out of space. That comes out to be a nice even 18. So the new base is 18 centimeters. We are in centimeters. Yes, we are. All right, Julius drew a trapezoid that had bases of 15 and 11 and a height of 4 inches. What is the area? All right, area of a trapezoid, 1/2. Add the bases times the height. So to find the area, we take 1/2 of 15 plus 11 times the height of 4. Area is, I'm going to take 1/2 of 4 right now and just put 2 times 26, which is 52. So 52 inches squared is the area. Can you draw a trapezoid that has the same area but different dimensions? Okay, let's think about that. So 52 needs to equal 1/2 of the bases added together times the height. Okay, now I'm going to multiply this whole thing by 1/2. I'm sorry, by 2 to get rid of the 1/2. So this would be 104 equals B1 plus B2 times the height. Okay, so there is a way, it says, there is a way to get 104 with different dimensions for the bases and the height. So yes, any sum of the bases times 4 must be 104. Sketch a trapezoid with the same height, but with bases that are a 5/2 scale factor of the original trapezoid. Okay, so 5/2, we're multiplying the bases by 2.5 is really what's going on. Okay, so we still have that 4 inches here. The original one was 15 and 11. So if I take 15 and multiply it by 5/2, I get 75 halves, which is 37.5. And if I take the other one, which was 11 back up in this problem, times 5/2, that's 55 halves, which simplifies to 27.5. So this guy would be 37.5 inches, and this one up here would be 27.5 inches. What is the area of the new trapezoid? Area equals 1/2. Add the bases together times the height. So I'm going to take 1/2 of 4, which is 2, and I'm going to add these together right here, which is, I'm getting my calculator out. My brain isn't working for that one. 27.5 plus 37.5, 65. And 65 times 2 is 130 inches squared. That is the new area. Okey-doke, next page. Mrs. Garcia. These are tough. These are hard problems. All right, Mrs. Garcia has a table shaped like an isosceles trapezoid. Okay, isosceles trapezoid means the two sides are equal in measure. The two sides are in her third grade classroom. The two parallel sides have lengths 6 feet and 8 feet. The distance between them, let me go ahead and make a picture of this. These are equal, isosceles trapezoid. All right, so we've got a 6 feet here and an 8 feet here. And the distance between them, so that's basically saying the height is 4 feet. What is the area of this table? So 1/2, add the bases together, times height. 1/2, 6 plus 8 times 4. Half of 4, I'll take that right now. 2 times 14, which is 28 feet squared. That's the area of Mrs. Garcia's table. Suppose Mrs. Garcia has a 1.75 feet by 0.8 feet puzzle on the table. How much surface area is now available on her table? All right, so this puzzle, 1.75 feet times 0.8 feet. Do not go by the looks of it. Okay, that is not drawn to scale. All right, the area of that would be 1.75 times 0.8, which gets us a 1.4 feet squared. So if we have the total 28 feet squared, and we take off this puzzle that's 1.4 feet squared, we still have 26.6 feet squared still available. A circular swimming pool with a diameter of 32 feet is located exactly in the middle of a 40-foot by 40-foot square lot. For safety reasons, the lot needs to have an 8-foot fence on the perimeter of the entire lot. How long will the fence need to be? Okay, so let's go ahead and draw a picture of this. So we've got this is 40 feet. This is, I'll put it over here, 40 feet. Okay, we have a circular swimming pool in the center. The diameter is 32 feet. Okay, and then it says the lot needs to have an 8-foot fence on the perimeter of the entire lot. How long will the fence need to be? Okay, so let's go ahead and do the fence around would be 40 plus 40 plus 40 plus 40. Okay, the 8 feet is there just to throw you off. It's 8 feet high. Okay, you don't need to worry about that in the calculation of the perimeter. Okay, so the perimeter is going to be 40 plus 40 plus 40 plus 40. Okay, I could have written 4 times 40, or I could have written 2 times 40 plus 2 times 40, or I could have written it out just like I did. However you write it out, you should have 160 feet. Okay, so the fence will need to be 160 feet. If the fence was around only the circular pool, how long would the fence be? All right, well, we're looking then for the circumference of the circle. So I'm going to just make a note here, need circumference circumference of circle above. So the circumference is pi d, 32 pi. Okay, let's use 3.14 for pi. And that gives us roughly a 100.48 feet. Okay, so the circular fence would be 100.48 feet. Explain how much longer a fence around the whole yard is than the fence only around the pool using percent increase, round to the nearest whole percent. Okay, so if I am looking for a percent increase over an original 100%, I want to compare what 160 is around the full lot versus the 100.48 around the circular lot. Okay, so when I cross multiply and solve this, let me come up over here. I'd have 100.48x equal 16000. And then I would divide by my 100.48, 100.48, and I would have an answer of 159.24. Okay, now remember that 100% is already in there. So if this comes out to be 159, there's a 59.24% increase. So about a 59% increase. What percent of the yard area does the pool take up? Round to the nearest whole percent. All right, so area. What percent of the yard does the pool take up? Area is going to be pi r squared. All right, so pi, now r would be 16. That comes out to be, I'm going to plug 3.14 in for this, and I'm going to square this, and that comes out to be roughly 803.84. Okay, so the pool area, 803.84 over the total area, okay, and I can also do it like this. So that would be 1600x equal 80384. And when I divide, let me get my calculator out for this one, by 1600. $803.84, 80,384, yep, divided by 1600. I get 50.24. So let's just say, it says the nearest whole percent, so about 50%. What percent of the area of the yard not taken up by the pool? Round to the nearest whole percent. Well, if this is taken up by the pool, wouldn't 50% not be taken up by the pool? Okay, we would just subtract this from 100%. Okay. All righty. Nico. We've got a problem about Nico. Nico is building a circular deck around the circular pool in his backyard. The pool has a radius of 15 feet, as you can see here. The deck will be 5 feet wide, as you can see here. Find the area of the deck. Okay, so we just want to find this. And the way that we're going to do that is we're going to find the area of the whole thing. Sorry, my circle was not very good. The whole thing. And then we're going to find the area of just the pool, and we're going to subtract them. Okay, so let's start with the whole thing, the orange thing. Okay, so we're going to have area equals pi r squared. Now be very careful. We need to add 5 onto this. So this is going to be 20 pi 20 squared. So that is 400 pi. I'm going to leave it like that for right now. And then I'm going to find the area of the pool, pi r squared, which is pi 15 squared, which is 225 pi. And the way that I need to handle this, and I purposefully left them with pi's because that'll be more accurate. 400 pi minus 225 pi gets us 175 pi. And if we multiply that by 3.14, that comes out to be 549.5 feet squared is the area of the deck. If Nico adds the 5-foot deck around the pool, what percent increase of the space will this be? Okay, so that's going to be, let's think about that. The area with the increase over 100% equals 400 pi was the whole thing over 225 pi was the original. These pi's go away. So I'm left with 225x equal 400 with a couple more zeros. Divide by 225. And I end up with this ugly number, 177.7 repeating bar. Okay, so remember that x has it's the area with the increase. Let me scooch that up, sorry. The area with the increase. So the increase in space is about 78% increase. Alrighty, that concludes lesson 7.1D.